Assalamualaikum and hi everyone. Today's video, I will continue chapter mechanical and sound wave for subchapter standing wave. There are few questions that we will discuss that relate to the standing wave. So take a look at question number 4. Question number 4 state that two sinusoidal waves travelling in opposite direction interfere to produce a standing wave as given by the equation there. We need to calculate the wavelength, frequency and speed. So first what we need to do is, we need to compare the equation given with the general equation for the standing wave. So when we compare with the general equation for the standing wave, we get that the amplitude is equal to 1.5 meter, the wave number is 0.4 and the angular frequency is 200 radian per second. So first, when we want to calculate the wavelength, we use the equation of wave number. We substitute the wave number inside the equation, and then you get the wavelength which is equal to 15.7 meter. The next question is to calculate the frequency, where we can use the angular frequency equation, and you get the frequency which is 31.83 Hz. And the last one, to calculate the speed of the standing wave. So we use the equation for the wave speed, V is equal to F lambda, substitute the frequency and the wavelength that we have calculated in A and B. So you get the speed of the standing wave which is equal to 499.7 meter per second. For question number 5, two waves in a long string are given by equation Y1 and Y2. If you refer to the equation Y1, negative sign shows that Y1 is moving to the right and Y2, which is positive sign, is moving to the left. So we need to calculate the position of the node of the resulting standing wave and the maximum displacement of an element in the string when x is equal to 0.4 meter. First step, we need to form the standing wave equation from these two progressive waves inside the string. And if you look at the solution, you will see that when we combine equation Y1 and Y2, we will produce the standing wave equation which is 0.4 cos 0.5x sine 40t. And because we want to calculate the position of nodes of the resultant standing wave, so we will take the amplitude of the equation which is given by 0.04 cos 0.5x. And then from the amplitude, we know that the position of node is when y is equal to 0 at the y component. So cos 0.5x, which is the amplitude, supposed to be equal to 0. When you calculate the x or the position of the nodes, you will get that x is equal to pi, 3 pi, 5 pi, and so on. So how we identify this one? You can take a look at this picture or at this graph. So here is y is equal to 0, and because of the first node, let's say this is 0, this is pi, 2 pi, here is 3 pi. Okay, so if we sketch the standing wave, graph of standing wave, you will get like this. This is the shape of the standing wave produced, and we can see that this is the node, first node, this is the second node. Okay, then the third node is of course at 5 pi. Okay, right? Alright. Okay. So I hope that you understand, referring to the diagram, how we identify the next node. Meaning that when we know from the calculation, we just get the first node which is at pi. And then the next node is refer to the diagram. You need to understand the shape of the standing wave. Now we calculate the maximum displacement of an element in the string when x is equal to 0.4 meter. So for the maximum displacement, which is amplitude, so we refer to the equation of amplitude and we substitute the x. When we substitute the value of x, which is 0.4 meter, inside the amplitude equation, so you get that the maximum displacement is equal to 0.039 meter. From question number 6, The velocity of the stationary wave is given as 300 meter per second. The amplitude is 2 centimeter or 0.02 meter, and the frequency is 100 Hz. So we need to calculate the angular frequency first. How to calculate the angular frequency? We just use the equation for the angular frequency, which is equal to 2 pi f. We substitute the frequency and you will get the angular frequency, which is equal to 200 pi radian per second. For question number A2, we need to calculate the wave number. Before we calculate, you need to find the wavelength of the stationary wave from the equation of velocity of wave. You get that the wavelength is 3 meter, and then substitute in the equation of wave number, you will get the wave number is equal to 2.09 per meter. And for the question number A3, the wave propagation velocity. We need to calculate the wave propagation velocity. So do we need to calculate? No need, because of the wave propagation velocity is given in the question, which is 300 meter per second. For question number 6A4, we need to calculate the particle vibrational velocity when the particle displaced at 1.2 cm from the equilibrium position. So for this purpose, we will use the particle vibrational velocity, which is equal to plus minus omega z a square minus y square. We substitute the y, which is 0.012 meter, and you will get that the particle vibrational velocity, which is equal to 10.05 meter per second. The question question number 5, the distance between two successive nodes is given by equation of half lambda. So we have calculate lambda in part 2, which is lambda is equal to 3 meter. When we substitute, we get that the distance between two successive nodes is equal to 1.5 meter. Now take a look at question number 6b. We need to write the displacement equation for the progressive wave. So first step, write down the general equation for the progressive wave, and we need to substitute the value of amplitude, angular frequency, and also the wave number inside the equation. So from the calculation and also from the given information, we get that the equation for the progressive wave as 0.02 sine 200 pi t plus minus 0.67 pi x. And the unit for this progressive wave is x and y in meter and t is in second. So for the 6c, we need to write the displacement equation for the stationary or standing wave. As usual, same thing, we need to write down the general equation for the stationary wave first, and next we need to substitute the value of the amplitude, which is equal to 2a, the value for wave number, and also the angular frequency inside the equation. Because of that, our stationary or standing wave equation is given by 0.04 cos 0.67 pi x sine 200 pi t, where the x and y is in meter and t is in second. Thank you for watching. I wish you all of you the best, and please show your support by clicking button subscribe, like and share. Thank you everyone.